Off the meeting. Can you give me co-host?
I was the first in, but I can't record.
Yeah,
Joel is the host.
It's recording. I don't know why it makes me co-host for you sometimes, but it does. So,
all right, great. All right, so feel free to stop me with questions in the middle, but I've got a pretty long set of slides here to talk through.
By the way, this is all based on your feedback, so your voice matters. Here we are less than a week after everybody voted on topics of most interest to them, and Brendan graciously agreed to kick us off with runners because it was the top voted item in the list. So thank you all for your feedback.
Yeah, and let me know, like I said, if you have feedback or questions, because it's a lot of information to be coming at you. So,
so do you have the link to the docs, Brendan? You can share.
Yeah, the link to the presentation is in the agenda.
Oh, it is. Okay, cool. I'll find it.
The word enablement, I think, is linked.
Correct.
To this
I see
slide.
it. Sorry.
Okay. Great. So today we're going to talk about GitLab Runners, and we're going to kind of do a deep dive into the specifics of the technical side of runners and how they work. So first, let's just talk a little bit about the agenda. We'll do a quick overview for anybody that might not be very familiar with GitLab Runners and how they interact with GitLab CI/CD. And then we'll go through the architecture of how runners interact with the GitLab server. We'll talk about different platforms and executors for the runner. We'll go to autoscaling and how that works. We'll look at security considerations, and then how to install some advanced configuration of runners. Question, how loud is it right now where I'm at? On a scale of 1 to 10, because it was a 0. Say that again?
There's definitely a little bit of background noise, but it's not disruptive.
Okay.
So quick question before you start, Brendan. I just have one question. What's the closest thing to runners comparable in the industry? What is that closest to?
The closest thing, although I hesitate to even say it because it's a bad comparison, but the closest thing would be slaves in the Jenkins world.
Thank you.
But I wouldn't recommend making that comparison, because once people start thinking that way, they lose a lot of the things that differentiate it from Jenkins. So I wouldn't recommend using that comparison, but that's the closest. So first, let's do a little bit of an overview. So these are just kind of some things. Oh no, my emojis will not work. Anyway, these are just some ideas that are taken from the runner page, but they're important to understand each of these. So first off, the runner is a piece of software that's multi-platform. So the runner is written in a pretty modern language called Go that runs on basically every platform out there. And so you can run the runner on almost any platform that exists. It's also multi-language, so it's agnostic to what programming language you're using. It doesn't really care about that. You can just use the runner for any language. It enables parallel builds, so builds don't have to happen in sequence, they can happen in parallel. It's built from the ground up for Docker, so that's really helpful, and something that is unique about GitLab CI/CD, that our runner is kind of built for Docker. And then one install of the runner can actually be many runners. So I can have the runner installed on a machine and have many instances with different executors, all running on that same single installation of the runner software. And then there's a pooled model for the job execution. So, basically all of the runners that I have are in a pool, and then as jobs come up for selection, the runners can pick a job from the pool of jobs to be executed, and then execute that job, but with exceptions, and we'll talk about that coming up. So any questions just generally about the GitLab runners or what they do?
Yeah, communication directions. So are the runners pinging the server looking for jobs? And
Correct.
Then, okay, great.
Yep. The runners are pinging the server, asking, what jobs are are there. And there's an interval on which they do that, which is actually customizable, which I don't get into in this. But on an interval, the runner is reaching out to the server and looking at the job queue and seeing if it can pick one of those jobs. Any other questions before I dive deep into the architecture? Great. So just this picture is from the website. It's like a really simple view of the architecture, but it's an important one to understand. So of course we have the GitLab server, right? That's GitLab itself, and that could be, you know, one server, or that could be, you know, a massive HA installation that has lots of different nodes, some that are doing front end, some that are doing back end. But for the purpose of the runner, it just sees, you know, GitLab, just like you or I would see GitLab at one URL, and that's the GitLab instance. And then you can have, you know, 0 to N runner processes on other servers. So we actually highly recommend against running the GitLab runner on the GitLab server. It works much better if you have a separate VM or a separate server or a separate, you know, even your laptop could be a runner. And so you can have 0 to N runners machines, and then 0 to N runner processes again on that machine, because one install of the runner can actually be multiple, run multiple copies of the runner for different methods. And so then to dig into the architecture a little bit more, there's 3 properties that are important to understand about a runner when we're talking about what jobs are going to run on what runner. And so these are the 3 properties. Basically, a runner can be a shared or specific runner. It can be a tagged or an untagged runner, and it can be a protected or a not protected runner. And so we're going to kind of dive into each of those things and what their implications are. So first of all, a shared runner is one that can be used by any project. So this is in a pool of runners that basically, you know, in most cases, you know, the GitLab admin, the DevOps team, the tools team that owns GitLab is going to also stand up some N number of runners that can be used by any project. So if I push a project today to gitlab.com, that's going to just by default use the shared runners that GitLab Inc. provides. And again, that's the model that most of our customers use to at least some extent too, where they have a set of shared runners that are run by the tools team. And then, you know, very typically that's going to be auto-scaled or scaled with either our auto-scaling or some other method of auto-scaling, so that you're smartly using compute cycles for that. Specific runners are ones that are tied to one or more specific projects. And so then they're only in the pool for their projects that they're tied to. And you can see here I differentiate between who manages them, right? So the GitLab admin is who manages shared runners, because they're only can be managed through /admin/runners, where only GitLab admins can get to. Whereas specific runners can actually be managed by whoever owns that runner, right? So again, your laptop could be a runner. Obviously, then you are the one that can manage what that's doing. And then so typically these are for like specialized builds. So for instance, if I need to build an iOS project, I'm going to need an OS X runner in order to build that. And so I might have specific for that. Or if I have a specific project that has specific requirements that go beyond what I can do with generic runners, I might have a specialized runner for that, or specific runner for that. And then the other thing I've seen organizations do is if they need to separate which group is going to be billed for which runners, then oftentimes they will use specific runners in order to label that.
So Brendan, can anybody create a runner then? As long as they have some permission level?
Yes, that's correct. Anyone can connect a runner. Anyone who is a project owner, I believe, maybe master, but definitely project owners.
And I could actually lay down the runner and then hook it up, right?
Correct. So again, you could have it be your laptop. So today you could hook your laptop up to GitLab.com as a runner for a project that you own.
Yeah, as long as you can see in the project's CI/CD settings the runner token, I think you can get to it.
Exactly. Yeah. So I've got the URL here, right? It's the namespace /project/settings/CI/CD. That's where you set up a specific runner for a project. Does that make sense?
That's great.
Great. Good. Okay, so then the next property is tagged versus untagged. So when you're creating a runner, you have the ability to give it a set of one or more tags. So this is useful again for, let's say you had shared runners, but some had Windows on them, or some had OS X on them, or some had, you know, a bunch of Ruby stuff that you needed installed by default, so you don't have to download it every time. This is a way you can tag runners, and then they're only going to run jobs that share their exact same tag. Or if the job has multiple tags, you know, they'll have to have all of the tags that match up. Untagged runners can be used to run any job, right? Jobs with no tags. So here we have an example on the left of at the top, this Win 2012 EC2 runner is a runner with Windows on it and has been tagged with Windows. And then the build step we see below, which is doing an MS build, is only going to run on runners that I've tagged with Windows, and that's just the tag I made up. And so because in order to build this, I need to be on Windows, I've used these tags to make sure that it doesn't try to run that build on some random runner or shared runner that's typically going to be Linux or might have Docker. Whereas on the right, we have a runner that's untagged. And then we have a Java project that has no tags associated with the job, and thus could be run on any untagged runner.
Hey Brendan, can I jump? No,
go ahead.
Question? Real quick, I think you mentioned it. Do the tags have to match exactly? So let's say the one up top, the runner you made said Windows and Java, had 2 tags on it, right? Mm-hmm. Do both those tags have to appear in the job itself, or does it just know that if it's at least Windows, it goes to that? Okay.
Yeah, the inverse is true, right? So the runner must have all of the tags of my job. Mm-hmm. The job does not have to have all the tags of my runner. So if that runner was tagged with Windows and Java, this job could still be picked by that runner.
Perfect. Thank you very much.
Yeah. But if I added a tag to the job of Java and I didn't add that tag to the runner, then that runner would not pick the job.
Thank you.
Mm-hmm. No problem. Any other questions relative to tags?
Just a quick question on that. The MS build, that script you have there, is that part of the YAML or is that a separate?
Yes, so the 2 items in black we're looking at are job definitions from a GitLab GitLab CI.yaml file.
Yeah. So can runners only be used with that, or they can use across the board?
I'm sorry, can you ask that again?
Okay, so can runners be used outside of CI/CD? I mean, how do you know what I'm saying?
No, the runners are only used to pick jobs from CI/CD. All right, and then the last property we'll talk about is protected versus not protected. And by default, runners are not protected, and so they can run jobs from any branch for any build. The reason to use a protected runner is if you want only jobs from, jobs from protected branches to only run on protected runners. So this may say, for instance, I want to have master as a protected branch, and I want to have that only run on protected runners. So this is typically used if there's like deploy keys on a specific runner. So I've got a specific runner for this project, and I've got my deploy keys on there. And so I only want that to run on master so that those deploy keys can't be exposed to someone nefarious that's just making a branch. And anytime something runs on it, I know that it's on master only, and thus has been reviewed and pushed by someone who has that permission. Does that kind of make sense, or questions on protected versus not protected? Cool, great. So those are the properties, except that's not all the properties. There's actually a couple more options. So I've got a screenshot of the runner options here. So this is obviously where I can protect a runner. I can also deactivate a runner. It basically pauses them. So instead of deleting the runner, if I need to do some maintenance or something on a specific runner, I can just deactivate it for now. It won't pick up any jobs until I reactivate it. And then there's also a thing called lock to the current project. So if we remember when I was talking about specific runners, shared versus specific runners, I said, are tied to one or more projects. So typically when you, not typically, but when you have a specific runner, you can have that specific runner locked down to only one project, or you can have it so that it's available to also be specific runners for other projects. So it wouldn't be able to become a shared runner, but it could say be used for another project. Unless I lock it to the current project, then this runner can only be used for one project, this project. Does that kind of make sense? Yeah, a little bit more complex, but worth mentioning. And then also I had skipped over untagged jobs. So for a runner with a tag, you could say, I don't want this runner to pick up any untagged jobs. Because even if I have a tag, I'm going to assume, oh, I can run other random jobs that are not tagged. But again, if I wanted this runner to only run specific jobs that are tagged for it, I would uncheck that box. I'm going to take silence as there are no questions, but again, feel free to.
That's actually helpful. I didn't realize that. So even if it's tagged, it can still pick up, it'll still fill in the gaps where needed.
Exactly.
Unless you have this checked, of course, right? Okay, that makes sense.
Exactly.
Cool.
All right. Oh, and then this is an example project that has a bunch of different kinds of runners on it. It has a Windows runner. It has some tagged runners. So if you want to take a look at what this looks like in GitLab, I'd recommend going to that. A lot of my screenshots are from this project, the CI kitchen sink project.
Brendan, I have a question that I don't know whether it fits in here right now, but it's about executing the runner on the client machine in the first place. So my understanding is typically have a one runner installation on your client computer. That might be your local laptop. And you can choose whether you register that runner with root privileges or without root privileges using sudo or not. That obviously is going to be a difference. And is there any general recommendations for that? My feeling is that when you do that, you will end up with two config toml files somewhere behind the scenes, one for the ones with root privileges and one for the ones without. And you would also need to kind of do the GitLab runner restart depending on what kind of privileges you want to use, right?
Correct. Yeah, so I do talk about our recommendations, I think, later on in the security section, but just generally to address that now, as with any Linux process, or any process on any computer, it runs as a user, right? So you're either going to run it as root or run it as your local user. And that has implications for security and for, like you said, where the toml gets stored, et cetera. So, but that's not necessarily a problem specific to GitLab Runner, right? Like that's just how the world of running processes, service processes works. But then there's some implications that we'll talk about later in the security section that go into like kind of our recommendations and things to be aware of when running runners in that way. Does that make sense?
Yeah, thanks. That becomes for me pretty important as soon as we start in auto DevOps and the security stuff, because I believe there are some requirements there.
Yeah, we'll talk about that. There's a security slide, so don't let me off easy when we get to that.
That's fine. Thank you.
Yep. All right. So next, I kind of want to talk about what platforms the runner runs on, and then what executors the runner runs. So those are two different things, right? The platform is the underlying OS that we're going to be running on, and then the executor is actually, there's a number of different ways that the GitLab runner can choose to execute jobs, and we'll talk about that. So first, platforms, right? Like it's available, like I said, it's in Go, so it's available for basically any platform that you can name. There's some that don't support Go, but almost anything you can name. So any distribution of Linux that it's out there, including we have packages for the big four. It can run on your Mac, it can run on Windows, it can run as a Docker service, it can run Docker machine, which is a very specific Docker driver we'll talk about a little bit later. It can run FreeBSD, and then it can run natively in Kubernetes. So basically, almost any platform you can name, you can then use that platform to run GitLab Runner. Then the executor. Oh, the emojis did not work. This was a really cool looking page until the emojis broke. So there's these different kind of executors. And so we're going to talk about them in detail next. And we'll talk about the kind of the most common and then the less common ones as far as what I've seen in the market. But the beauty of the GitLab documentation is, as you can see at the bottom here, there's a section of our executor docs called I am not sure what executor I want to pick. And that really helps users make a decision about what executor is right for their specific use case. So first, let's talk about the four most common. So that would be Shell, Docker, Docker Machine, and Kubernetes. So Shell is exactly what it sounds like. This is directly running commands as if I'm writing them to the terminal. So bash or sh in Linux, or the command prompt or PowerShell in Windows. So this is as if I was a human being typing those into the terminal, again, as Gronk pointed out smartly, as the user that the runner is running as, typing those commands and executing them in parallel. This is really helpful for like low-level stuff you want to do. If you're running your own runner on your machine, it's helpful because it's super easy to debug. There's no complicated layers between you and the runner. And so that can be really helpful. It's also really helpful in the Windows world because Windows and Docker still don't play nice perfectly all the time. And so it's nice to be able to just run bash scripts basically for Windows builds and run Windows and like ASP.NET and those kinds of things have the MS build exe, which makes it really easy to execute that with the shell execute. Then next is Docker. That's probably the most common executor. And so what this does is it says, first spin up a Docker image, then execute everything in my script inside that Docker image. So this is, again, the most typical build and really where a lot of the power of GitLab CI/CD comes from, because as a developer, I can just choose the image I want to start from with all the dependencies I need, and then build inside of it. And then that image goes away and is dead at the end of my build. And it's very ephemeral. And I don't have to worry about anything on the machine or having a specific machine be turned on and connected. It's really useful for that. The other really useful tool is Docker Machine. So Docker Machine is a specific driver from Docker where there's kind of like a master machine that can then scale up runners with demand. And so this is very typical in cloud deployments. And I think we talk about it a little bit later, but most cloud providers support this, and then many on-premise private cloud type supporters tools support this as well. And so it allows you to scale up and down with demand, just like the Kubernetes one does. So the Kubernetes executor is similar, but it actually runs the build as a pod in the Kubernetes cluster. And again, that also then brings you some native auto-scaling options around how that works. Questions about any of those executors?
Yeah, quick, Brendan, on that. And maybe this is a new question or whatever. Docker Machine, I see, is that the same thing as Docker and Docker? Is that?
So no, Docker Machine is a way that Docker drives creation of new virtual machines, basically, right? Okay. So you can think of it as Docker virtual machines. So for instance, on AWS, I can use Docker Machine to spin up a new EC2 instance, which is, and we'll get into that a little bit later. Docker and Docker means I'm inside of a Docker image, but I also want to be able to have Docker running so that I can then build Docker images from inside a Docker image.
Like Inception.
So those two things, yes, like Inception.
Okay.
Exactly.
Yeah, quick question on there.
Go ahead.
Yeah, one question is when you choose the executor to be Docker when you register the runner, you will typically you get asked to give it a Docker image. I understand that as a default image, but I have yet to see a GitLab CI YAML file where you wouldn't define what the image actually is. But if you define, let's for example, if I'm giving on the registration of the runner, if I'm giving it an Alpine image, and then in my YAML file, I simply say, well, I'm going to use JDK8 here or something like that. That will override the default. Is that correct?
That's correct.
It's overriding a default. Another thing is I have a setup here that I'm using where I'm using Docker machine manually to create a virtual machine running boot to Docker as a distinct Docker execution environment, well, kind of isolated from my Mac, basically. In order to talk to that, I'll still use a GitLab runner with the Docker executor as such. So it's sometimes confusing, but I might be using as a user Docker machine to have a Docker environment, but I would still be using a runner with the Docker executor and only the Docker machine executor when I want the auto-scaling, right?
Correct, correct. The Docker machine executor basically auto-scales up additional machines, which then have their own executor, right? So it gets a little, a little complex.
Yeah, it is.
So
and if then Docker and Docker runs in there, then I have kind of 2 dimensions of indirections. Is that sort of my right understanding?
But yeah,
kind of complex.
Yes, yes, that's pretty accurate. And yeah, so the default image when I'm using the Docker executor is for the instance, and it's just in case you don't specify an image in the YAML. It's not really useful for us as GitLabbers because we're supporting languages like every language. But if I was a shop that was focused on Node or focused on something else, then that could be useful because maybe I do kind of have one go-to language, right? But for us, yeah, I think we're specifying an image every time because we're demoing someone Java one day and Node the next day and Ruby the next day, right? Any other questions? All right, hope you're all still there, but because I can't see you. Next, we're going to take a look at some 3 of the less common executors. So VirtualBox can be an executor. This is basically where you specify a base virtual machine for your runner in VirtualBox, and then kind of that master runner again creates a new virtual machine for each runner. So that's similar to Docker machine, but a little less universal. It's just for VirtualBox. But actually, it's also for Parallels too, because Parallels for Mac is really just a nice platform on top of VirtualBox. Just don't tell anyone, but that's what you're paying for. And then there's also an SSH runner, which is similar to Shell, but a little bit different. In this case, the SSH executor would first SSH. You would SSH into that machine and then execute commands on that machine. So if I don't want runner installed on that machine, but I want to be able to execute commands during my build on that machine, this kind of lets me do it. But again, it's a little bit more limited because this is only really supports bash. The cache really isn't supported in this. And so it has a limited set of use cases, but it's valuable when you need it.
So Brendan, do we support VMware or just VirtualBox?
Just VirtualBox. VMware actually supports Docker Machine for scaling. And so you can use Docker Machine with a number of VMware tools, which we'll talk about in a little bit.
Okay.
All right, so let's talk about auto-scaling runners. So again, there's 3 different auto-scaling methods. This is where we're going to dive into it, right? So there's AWS. I've separated out. AWS actually uses Docker Machine, but there's some specific things to AWS that I want to talk about, which I think are important. There's Docker Machine, which again works with most cloud providers. Docker shows examples of DigitalOcean and AWS, but then you can also see the massive list of drivers that exist that are supported by Docker for Docker Machine, which includes VirtualBox actually, and then includes 3 VMware tools: vCloud Air, Fusion, and vSphere, and then a number of other tools, as you can see. And then last is Kubernetes. So we'll talk about how the Kubernetes scaling works as well. And just real quick, can I get a time check? I have no idea what time it is either.
You have still about 25 minutes.
Awesome. Cool. Great. All right. Okay, so let's first talk about Docker Machine. So again, Docker Machine is a driver from Docker that allows you to create machines on demand. And so basically, to configure this for GitLab, I can configure a global job limit called concurrent, which is how many jobs all runners, local and autoscale, can be executed at one time. But then I can also limit the upper limit of machines that are going to be created by the executor. And then I can also set an idle count and idle time, which is really useful. So this says, always leave 2 machines on, but scale up to 10 when needed. And then when those machines are not needed anymore, allow them to be on for X number of minutes to see if another job comes up. And so this is useful and just can help speed up the builds, right? So here we're balancing smartly using compute time with speed of builds and not waiting for a machine maybe every time I have a new build. And then actually there's even more advanced features where I can do an off-peak configuration so that at the start of my business day, I can have it scale up and have two idle machines at all times at least. But then at the end of the business day, scale down to 0 or something similar to that. And then in this scenario, there's some also advanced consideration for caching, because now the runner cache for a given pipeline is not contained within one runner. I have to have a smart plan for distributed caching if I'm going to use caching across jobs in my pipeline. And next we'll talk about AWS, which will help make this a little bit more real world for anybody. But any questions before I move on from here?
Yes, of course I have questions on that one, Brendan. I'm sorry. According to the documentation, you can, in that runners.machine section of that YAML file, you can provide machine environment variables. So you
Correct.
can put stuff into the machine environment. And I'm interested on what would you do, because you can also put environment variables into the GitLab CI YAML file.
Uh-huh.
And I'm looking for kind of best practices on where I put my environment variables. That I'm particularly interested in everything proxy settings, because this is kind of most important to enterprise environments. So I'm currently working on an opportunity where that really is an issue, that we need to have kind of proxy settings on it. And the question would be, where's the place to do that in that machine environment? So basically, because my understanding is when you put it in that section, this becomes a parameter to Docker machine create, what effectively gives that Docker host this environment variables. But there's
Correct.
still the ability to do that in the CI YAML file. Where do I do it?
Yeah, I would say in the proxy use case that the best place to do it would be in the Docker machine section, because then that means that my developers don't need to know anything about the proxy environment. They could, but I'd want to be able to provide them a service that they don't have to think about, right?
It's pretty much an infrastructure thing, not a project
it's more of
thing.
Yes, it's more infrastructure specific than it is project specific. So again, there's no right way, but if I was doing it, that's the way I would do it.
Yeah, I'm having issues, but it's probably too much for this call. But I'm having issues when it comes to Docker and Docker on this specific situations. Not always these environment variables seem to be honored. But,
sure, there should be ways to fix that, and we can talk about it, like you said, probably not on this call.
Yeah.
But I also do talk about proxying later on in the presentation. So
cool. Thanks.
So, Brendan, quick question.
Go ahead.
So is Docker dash machine and that whole CLI is the same as Docker plus machine, or is it different?
In which?
So there's a Docker dash machine, the whole CLI around that Docker has. Is this the same as Docker plus machine, or is this different?
I think that's exactly what it is.
Exactly the same. Okay.
I think they're the same. Yeah, it's actually Docker space machine, or no, maybe that's Docker dash machine CLI. Yeah. I mean, it's the same thing. We're using the Docker machine. I'm not sure about the syntax, but
got it.
But yeah, we're using the Docker machine driver from Docker. Okay, so in AWS, again, we can scale up instances in AWS using this Docker machine, but there's some specific considerations for that and some specific benefits you get just because of the way AWS structures what they do. First off, of course, to spin up a new machine in EC2, which is what Docker machine is going to be doing, I'll need access keys that have the ability to do that. And then, of course, I'm going to need to specify a region, specify what VPC, subnet, and security groups are going to apply to that machine. And then I can also tag the machine with EC2 tags. So again, that can be very valuable when it comes to billing perspective. I can actually auto scale and bill back however I need. And then also, of course, I'll specify the instance size. And for those that might not know what EC2 or S3 is, I've got 3 links here that you can go to read more from Amazon. So S3 is the 3 S's or simple storage service. And basically this gives you a really easy way to handle the distributed cache problem that I was talking about earlier. So if I specify that all of the runner caches go into S3, then I just very simply are able to share that cache among runners. And then spot instances. So spot instances are basically unused compute in the EC2 world that you can bid on and get that compute at a massive discount. And so we actually provide the ability to specify your bid price and the block duration to be able to bid on unused compute and actually really reduce your runner costs even more. There's actually a blog post out there that talks about reducing their costs on EC2 by 90% when moving from Jenkins, which would have slaves that are running all the time, to auto-scaled GitLab with spot instances. And so that's a huge benefit for large enterprises that might be doing a lot of builds at scale. Questions about AWS? Great. So lastly, we'll just talk about Kubernetes. So again, there's some special considerations to think about for Kubernetes, which are just Kubernetes specific things, like if you need a volume to be attached to, what namespace you're going to go into, what you're going to limit CPU and memory to. You can deploy these with Helm. So we have a Helm chart for the runner that can deploy GitLab Runner into Kubernetes cluster. But we also have the ability now to, with one click, if you've connected your GitLab project to a Kubernetes cluster, deploy a runner with one click. And that's kind of just a single runner, but then auto scale runners in Kubernetes with a similar one-click installation button is coming to a GitLab near you soon. Any questions about Kubernetes-based runners?
Yeah, quickly. Helm is pretty much the equivalent of installing the runner, but it's not registering an individual runner, I guess. This is a separate task. And who is then doing that?
Correct. Yeah, again, this would typically be done at the instance level, but now with the project specific, it can be done at the project level. And again, both with Docker machine and with Kubernetes, with both of these scaling options, GitLab is handling, as it creates a new runner, registering that runner, right? Does that make sense? So with Docker machine, I'm going to create a new EC2 instance. It's going to spin up. It's going to have GitLab Runner on it, but I'm going to have it installed and registered automatically. Same with the Kubernetes executor. I'm going to spin up the runner in a pod. It's going to be registered automatically.
Yeah, there will still be TOML files lying around somewhere, right?
Correct. So with Kubernetes, the TOML file, typically we recommend, and this is detailed in the documentation, that be a configuration map, which is a primitive that Kubernetes provides, so that you can manage it like a Kubernetes service is managed. That's just kind of Kubernetes best practice. And then the TOML for Docker machine is on whatever master is spinning up your Docker machine files. So like, for instance, when I spin up a large AWS instance, I typically spin up a pretty small micro instance to be the Docker machine instance, and the TOML lives on there for the configuration. And we're going to talk about the TOML for people that don't know what Gronk and I are referring to later.
That was my next question. Thanks.
Great. So first, before we get to that, just some security considerations. First of all, there's a great page on security on our runner documentation. Right? Like basically this entire presentation is brought to you not from Brendan's brain as much as from GitLab's amazing documentation. So I definitely encourage everybody to read that. But I did want to bring up some of them here, right? So the first one is for the shell executor. So this is going to run commands as whoever installed GitLab Runner. And so if I sudo install GitLab Runner, it's going to run as root. And so because it's running as that user, it has those user permissions on the system. And so if that user has sudo rights like root, that can be dangerous if someone wants to do nefarious stuff to your system. The Docker executor, on the other hand, is very safe, especially in non-privileged mode. In non-privileged mode, the Docker works as designed to just kind of only give you access to the one environment in Docker that you're running in. Now, if I run it in privileged mode, though, that can have similar problems to Shell, because in privileged mode, I can kind of work my way out and access the system directly.
Brendan, I need to ask something here. Sorry about that. But this is actually, with AutoDevOps and with the security products, we have running the Docker executor in privileged mode being a mandatory requirement, as far as I understand it. This opens up a can of worms, as in conversations with prospects, we're having the thing like security fighting security. So we are selling security products to security aware people. They then, by the same time, raise kind of concerns because we are using a privileged Docker executor, opening up security issues to them. Is there anything, any kind of way how to properly address that? Because it's a tricky discussion.
I mean, so the thing I would say, yeah, sure, it's a tricky discussion. One thing I would say at first is, if you're auto-scaling runners, it takes away a lot of that concern, because this is a machine that, yes, even if you're running on privilege mode, it's a machine that you could care less about, theoretically, right? For instance,
I've done the same thing with, and that's sort of solved the problem. I said, if you, with, well, Docker machine, create a virtual machine, not with the autoscaling stuff by itself, but just really creating a separate Docker environment, then you would be actually safer by using privileged mode, because you do not worry about that, because it's a specific virtual machine that has been created. Is that a fair statement?
Exactly. And the analogy I would use is, look, we do this at scale on GitLab.com. So think about the nefarious actors that can sign up for GitLab.com and try to do a bunch of stuff, right? And this is, the entire world worth of it. It's not even just our organization that can access it, right? And so our security team all the time is finding, the new ways that people can try and take advantage of that, because we provide free compute on GitLab.com. And that's the reason on GitLab.com that we auto scale stuff, because then, we're not giving someone access to our production infrastructure. Obviously, we're just giving them access to one, node that was spun up for them to do their job. And it's really, very little that they can then do, even if they break out at that point. And so the fact that we run the same code on GitLab.com, which has, internet scale security issues, should make organizations feel like, they should be able to leverage our knowledge in that and protect themselves.
And by the way, my experience while playing with that, it is actually possible to do it all on your laptop, on any given computer. But as far as I understand.
Yeah, you can do all of it. Mm-hmm. Then just the last three security concerns here. So the SSH executor today does not have host key checking enabled, like the stringent SSH host key checking enabled, which means it could be susceptible to man-in-the-middle attacks. And again, just as another maybe thing to be aware of if you've got the SSH executor enabled. And then the last two, Ron touched on one earlier, but using with a proxy. There's a very specific documentation page about how we recommend using it with a proxy. If your proxy requires authentication, making sure that authentication happens at the right layer on the machine you're running. How to configure GitLab Runner to use those proxy variables that then configures the Docker containers within them to use the proxy variables. We could spend a whole half hour on that, but there's a great documentation page on it. And then also the self-signed certificate question. So this comes up a lot with customers. The easiest answer to this is we use the certificates on the system. And so if you've got the system that we're running on configured to properly use your self-signed certificates, you shouldn't have a problem. Now, you can also place a PM file in a very specific location. I'm not sure what it is, but in the doc you'll see it's, etc GitLab Runner or something. Or when you're configuring the COML, you can actually point us to a specific place where the certificate exists. And so those two are options as well. But I would say if I was doing it, I'd want to manage the machines the runner running on separate from the runner itself, and then GitLab Runner wouldn't need to know anything about that. It would just work. Any questions about that?
Yeah, one final one, and then I shut up. On that proxy kind of stuff, I have a little bit of the feeling that I can define HTTP and HTTPS proxies, but there is struggle with no proxy definition. Is that I found that not to work.
Yeah, I'm not sure. I haven't had experience with that specifically, so I'd have to look at it with you. But yeah, I'd have to look at it. And again, a lot of it, I think we should put as much as possible onto the system that we're running on, because that's a much more maintainable thing than us having to know everything about the proxy in order to get it to work. Okay, so next, let's talk about installation and then a couple advanced configuration topics, aka this TOML that you've heard us alluding to throughout. So first of all, the installation, of course, is a great piece of documentation on it, but it's pretty simple. You basically get the binary for your system. You can download it from our package management system, or just download the binary itself that's correct for your system. And then you make sure that is executable. And then you run GitLab Runner register, and you can see I've got that process here, basically the details I need. So I need the coordinator URL, which is my GitLab instance. So in this case, I registered a runner to gitlab.com, but that could be my company's instance. I give a description to the runner that just basically is the name that displays in GitLab. I can add a comma-separated list of tags for this runner. I can decide, again, that checkbox of does this runner run untagged builds or not? And then I can also say, am I going to lock this runner to this project or allow it to be set up as a runner for other projects? And then it registers the runner and it asks me for my executor. You can see the list of executors there. And actually it will, if it's already running, it will automatically pick up the configuration and you don't need to reload. But if you're not running, you can then just run install and start to get it running. Questions about installation? Great.
So where are you getting the CI token? Is that from CI/CD?
So the CI token is either, if you're the admin, the CI token is going to be in /admin/runners, right? As we saw way back at the beginning when it's specific versus shared runner slot.
Okay.
And if I'm a project owner and I want to register to my project, it's under project settings CI/CD runners to get that token.
Okay, so you get it from the GUI too. Okay.
Yep, you get that from the GUI. All right, then last, we'll look at config.toml. So toml is just another markup language. I'm pretty sure it's Tom's other markup language or something like that. So just when you thought YAML was the last one you'd ever need, here comes toml. So this toml file basically defines all of the things that we need to know for the runner to run. And that registration process we just saw is basically writing the minimum required items to create the config.toml. But then I can be a little bit more advanced and configure some more details within it. So here we can see that there's a global settings at the top level. This is, again, for this entire runner set of runners, how many concurrent jobs can run, and then things like log level gets up there and proxy stuff. And then each runner that this GitLab runner instance is going to run is started with one of these runners tags. And then again, some generic information about that runner, the token it's going to go to, the URL it's looking at, what executor it's going to use. And then depending on the executor, you're going to have, you might have specific executor definitions below. So here I've included all of them, or many of them, but you won't actually have all of them. You would have one or the other. So you could have like Docker, you could have VirtualBox, you could have Kubernetes. There's specific, the specific considerations we talked about are going to be found within this kind of sub settings area. And then there's also the runners.cache that defines where I'm going to put the cache, if not in my local system. So if I want to put it into S3 or something like that, that's a section where that gets defined. Again, great documentation on this. It's called Advanced Configuration of GitLab Runners. If you want to see like all the details behind it, I just wanted to kind of demystify this in general. All righty. So now the question is, any questions that I haven't answered already?
One last question on that, the TOML file just showed. You just mentioned, and you covered my one question, you have multiple executors in there, right? But I think you just did that for example, right? Which is cool.
Yes, that's just for example.
Cool. But you could have, but you could have multiple configs. You could register additional, am I saying that right? You could have additional
Correct.
config files on that machine. Yeah, okay, gotcha.
You'd have one config file, multiple runner definitions. So see where I have single runner definition pointed to, and then everything else below is underneath that.
Yep.
I could have another runners, double bracket runners, and then define another runner, right? So I could say, here's a shell runner on this machine and also a Docker runner.
Oh, okay. So it would all be in here in one file. Okay.
It would be in one file, and
Gotcha.
then you could have multiple. The basically from the runners line down, that could be repeated multiple times.
Okay. Thanks, man.
Any other questions? And then also, of course, we've got to end with a slide of just GIFs.
Oh,
And now Chris is happy.
this is happy. Hey, Brendan, did you go through real quickly? I think a lot of people asked out loud, but do you want to look at the questions on the side real quick? Looks like
Oh, yeah, sure. Sure.
but I just want to make sure.
Sure thing. Yeah. And me explaining this whole thing is obviously the top right GIF, if anybody didn't pick up on that.
Pepe Silva. That's great stuff, man.
Let me just stop sharing and get back to this. Chat questions. Okay.
So Chris is on a delay. He probably just saw it.
Doing builds in a Windows environment. So I think I covered that. DT, if you have other questions about that, let me know. Yeah, you just run it on a Windows box. So easy. Just going through, how does shell different from SSH? So shell runs directly on the computer that I'm running the runner on, whereas SSH can first SSH into, oh, John Wood's answer. Never mind. Yeah, you can SSH into that. Chris feels better because there's more GIFs. Thank you, Luca, for the link to the security page. Yeah, okay. Anything else